everybody. So we're going to look a little bit more with negative exponents, and this time using some multiplication properties. So again, many ways that we can take these problems. In some cases I'll show you a few different ways. Over here, if we look at problem number 1, we have 3 times x to the negative 4th power times x squared. So what we need to remember here is that when we multiply like bases, we're going to keep the base and add the exponents. So the 3 is going to come down here, and we're going to have our x as the base, so we're keeping the base. When we add a negative 4 to a positive 2, we're going to get a negative 2. Now in math, it's not proper to leave the exponent negative. We always want to write with a positive exponent to be all the way simplified. So if you remember, when we have a negative exponent, we take the reciprocal of the base, so it goes from the numerator to the denominator, and then we change the exponent to a positive value, and we can call this problem done. If we take a look at number 2, again we have multiplication here, and we're going to multiply the coefficients the same way we normally have, so 5 times 2 is 10, and I'm going to put the x's next to each other just for now. So really what we're doing here is we are multiplying like bases, and when we do that, when we multiply like bases, we keep the base and we add the exponents. So negative 2 plus a negative 3 is a negative 5. And again, when we have a negative exponent, it's not proper to leave it that way. So we're going to leave the 10 by itself. The 10 does not have a negative exponent, but we're going to change the place of the x. So we're going to take the reciprocal of that. So it goes from the numerator to the denominator. We're going to change that exponent to a positive 5. And so we have 10 divided by x to the 5th power. Now in number 3, the property is used a little bit differently because we are raising a product to a power here. So when we raise a product to a power, we keep the base and we multiply the exponents. So one of the things to remember is that everything in this set of parentheses gets raised to the negative 2nd power. So just so that I don't forget, I'm going to put a 1 there to remind myself that I also need to multiply that 1 by the negative 2 as well. So this 10 to the 1st power becomes 10, and then 1 times negative 2 is negative 2, and then a to the negative 4th raised to the negative 2nd power. Negative 4 times negative 2 is a positive 8. And one more step that I have is just to deal with that negative exponent here. So it's not proper to leave it that way. The a to the 8th is going to stay where it is, and this 10 to the negative 2nd is going to move down here, and it's going to become a positive 2. And we're going to just simplify one more time. 10 squared is 100, and so we get a to the 8th divided by 100 over here. So taking a look at number 4, it's very similar to number 3. We are raising a power to a power, so we keep the base and we multiply the exponents. So negative 2 times negative 1 is a positive 2, and 5 squared is like saying 5 times 5, which is 25. And then we can call that one done. Number 5 is very similar to number 4. We're going to keep the base and multiply the exponents together. So negative 3 times a positive 2 is a negative 6. And again, not leaving that negative exponent the way that it is, we are going to move that 2 to the denominator, and the negative 6 is going to become a positive 6. So we have 1 divided by 2 to the 6th, which is 1 divided by 64. Remember that that is like saying 2 times 2 times 2 times 2 times 2 times 2, or 8 times 8, which is 64. So thinking about it, when you have something being raised to a negative power, you don't get a negative answer. This is still a positive answer. is just a very small answer. It's tiny. And now let's come over to number 6. So we have to take this one in a couple of different steps here. We are raising a product to a power and a power to a power. So PEMDAS tells me I work inside the parentheses first if I can, and then raise to the power. So there's nothing I can do to simplify in here. I don't have any like terms to combine. So I'm going to first put that little 1 there so I don't forget. When I raise this to a power, I'm going to have 2 to the -2nd because I keep the base, multiply the exponents. And 4 times -2 is a -8. So I'm going to leave this for now. And I'm going to come over here to the second set of parentheses. I'm going to keep the base, multiply the exponents. So now I'm going to deal with all these exponents and think about what happens when I multiply like bases. So 2 to the -2nd is like saying 1 over 2 squared. So I'm going to move that 2 to the power of 2 to the bottom because that's a negative exponent. Now over here, when I multiply like bases, I'm going to keep the base. I'm going to add the exponents together. So -8 plus a -6 is a -14. And so now I have to deal with this simplifying a little bit more here. This is negative, and I don't want to leave it that way. This 2 squared becomes 2 times 2, which is 4. That a to the -14th is going to come down to the denominator and become a positive 14. I have 1 left up there. And so I have 1 over 4a to the 14th power. And now that's it. Bye, guys.